So let us look at some reviews on triangle proofs. So first, we need to write down 5 ways to prove triangles being congruent to each other. So first method would have been, as we know, SSS. In other words, all 3 sides has to be congruent, meaning all 3 pairs of the sides has to be congruent. So if I were to draw one triangle, okay. Now, if I were to draw another triangle, even though how they look, let us say this side is equal to this side, and this side is equal to this side, and then third side is equal to its corresponding size. Then we can say 2 triangles are congruent by SSS postulate. Second one would have been this, SAS. Notice that angle is between 2 sides. So once again, if I have to draw a picture for that, now, assuming that this side is congruent to this side, one pair, second pair is congruent here, that means angle between them also has to match in order for us to use SAS postulate. Alright, let's go for the third one. It will be, instead of side angle side, we could have angle side angle, ASA. Then, in that case, the triangle could have been something like this. Now, we have one pair of the angle are congruent, and let us say another pair is congruent here. Notice the side is between those 2 angles, so the side between those 2 angles has to be also congruent to each other to show that we can use angle side angle postulate. Now, another thing is we could have angle angle side, AAS. But the major difference between number 3 and number 4 is that on number 3, side was between those 2 angles. In this case, side is not between those 2 angles. Meaning, if I have one triangle and 2 triangles here, I have one angle, second pair over here that are congruent, then side that which we are looking to be congruent is not the one between but one away from, such as this one. Then we will have angle, angle, and side. Lastly, we have HL. Now notice that all the other things has 3 letters, meaning we need 3 conditions to show that those 2 triangles are congruent. On number 5, we have 2 letters, hypotenuse and leg. But in fact, even though it's a hypotenuse and leg, the third condition is that it has to be only coming from the right triangle. So that's why, in one way, number 5 still has 3 conditions to it. So let me just give you one such example here. So let us assume that this side is, let us assume that this is a right angle and this one is a right angle, meaning those are right triangles. Hypotenuse has to be congruent, and one of its leg has to be congruent. So then, as you can see, we are looking at hypotenuse, leg, and hypotenuse, leg. So HL postulate. Now, next, in many proofs, after we showing that 2 triangles are congruent, we tend to write something called CP/CTC. That simply means corresponding parts in congruent triangles are congruent. That's what basically CP/CTC stands for. Alright, now let's move on to the next. 3 ways to prove triangles are similar. First and most popular method will be AA. You need to show that 2 pairs of the angles are the same. So even though they might be in same, they may not be in the same size, but as long as one pair of the angles are the same and second pair of the angles are the same or congruent, then you will realize that these two triangles are similar. Now we have second and third method. Next one will be SSS. Now these two are less popular compared to number one, but we're gonna talk about them here. SSS basically postulate means that when you have two triangles, their sides are in proportion, all three pairs of that. So if I have one triangle here, and another one, and let me call this side as side A, B, C, and the second triangle I'm going to call it A prime, basically another A, B prime, and then C prime. Then we have to realize that the proportion A over A prime, that ratio, meaning between two sides, that ratio has to be the same for B over B prime, and so as C over C prime. Then we can say those two triangles must be similar. It's called SSS postulate in similar triangles. Next one would have been SAS. In this case, SAS in similarity basically means I have one triangle, I have second one, so A prime, one pair of the sides are in proportion with the second pair, but the angle between them happen to be the same. So number 3 in one way, it's a mixture between number 1 and number 2. So it has to have two conditions. A over A prime is equal to B over B prime, but at the same time, the angles are the same. Now, so that's how we can prove the two triangles being similar to each other. Let us look at some practice questions here. Number 1. HK bisects IL. That means IL is being bisected here. That tells us that IJ is congruent to LJ. And angle H is congruent to angle K. Then notice that we have two conditions so far. What is the most direct method of proving these two triangles being congruent to each other? It seems like, since we have two lines crossing each other, we can say that these two are vertical angles. Angle IJH and then LJK. That tells us that these two triangles must be similar by angle, side. So angle, side, which is choice 3, would have been the most direct way of doing it. All right, let's look at the next question here. Notice that BAT is and then we realize angle B is congruent to angle F. That means those are corresponding angles. And then angle side AB is congruent to side FL. Now, which statement is needed to prove that these two triangles are congruent? Angle A and angle L. Will that be the case? Angle A and angle L? Yeah, that would have been correct, because in that case, this would have been angle, side angle. So, first one is okay. So therefore, this one is okay. How about the second one? Angle, line segment AT and then LU. AT is this one, and LU is this one. Then this would be side angle, and that's not something that which we are looking for. Side angle is not the way for us to prove that two triangles being congruent to each other, so that's out. Angle A and angle U. Angle A and angle U. Notice that angle A makes up side angle side, but angle U doesn't make side angle side. In other words, the congruent pair of the side is not between those two angles here, when in fact it is here. So therefore, number 3 is also out. And then line BA being parallel to FL. In fact, that doesn't matter because we don't have any line that's connecting them, so-called transversal, to create corresponding angles or alternating interior angles. So we have no idea about that portion, so number 4 is out. Therefore, the correct answer was choice number 1. All right, so here we have, first, this is similar to what we have done earlier, but we have this one in terms of proofs. So we'll try to do both of them together. So here we have statement, and then here we have regions. So first we're going to write down the givens. HK bisect IL, and angle H is congruent to angle K. That's given. Let's try to mark that. HK bisects IL, that means that line segment and that line segment must be congruent to each other. And angle H is congruent to angle K. So as a second statement, we have to write down IJ must be congruent to LK, or LJ. Why is that? A bisector cut a line segment in two congruent parts. Alright, so now let us move on to number 3. We have two conditions. We will be needing third condition in order for us to show that those two triangles are congruent. In fact, HK and IL are straight angles, straight lines. So therefore, we can say those two angles must be congruent. Why is that? Yes, it is because they are vertical angles. So I can say angle I, J, H is congruent to angle L, J, K. Because vertical angles are congruent. Number 4. Now, because we have all three conditions, so we can say triangle HJI is congruent to triangle HLJ. And what would be the reasoning? It would have been angle, side. You can see that over here. So in fact, here you can see that we finished the number 1. Number 2, we need to show that HI, which would have been this line segment, is congruent to KL. How would you do that? Wait a minute. These two line segments are the corresponding sides from those congruent triangles. So we don't even have to go any further. We can just write down number 5 here. I'll say line segment HI is congruent to line segment KL. Why? The famous CP, CT, C. All right. Let us look at number 4. So here we have angle KAB. That angle is congruent to CAB and the CED. Those two angles are congruent. How can we show that those two triangles are similar? We have to look for the second pair of the angles. How about that? By vertical angles. So that's why we can say by AA, those two triangles must be similar. Now number 5, here we have a right triangle and a case, so that all those things are given. But notice that we need to prove this one. How can we prove the proportion? Proportion actually comes from the similar triangles. So then, if we can show that there are two similar triangles, then hopefully we'll be able to do this one. Similar triangles which we can see would have been the small one and then big one. So let's try to look at what we can do with it. So statement, and then the regions. First, triangle DLW is a right triangle, and then KC is perpendicular to LW. Now, those are givens. Number two, technically, even though it's just simply right triangle, we cannot assume that which angle is the right angle. But in this case, we can visually see that angle L is a right angle. The reasoning can be anywhere. I'm just going to write down the most general one, which is in a right triangle, there is a right angle. Now, I can even write that down as shown from the figure or things of that sort. That's also perfectly fine. Now, number three, remember how we had our perpendicular lines? That means we will see that measure angle CKW is a right angle. Why? Perpendicular lines form right angle. Then step number four, because those two are right angles, we can say angle L is congruent to angle CKW. The reasoning will be all right angles are congruent. All right. Now, we only showed one pair of the angle. We need the second one. So we talked about this angle is congruent to this angle. How about angle W? That's right. Angle W is congruent to angle W. Why is that? It will be the reflexive property. Reflexive, right over here. All right. Then we can say that those two triangles must be similar. So we can say triangle DLW is similar to triangle CKW. Why is that? A partially, because we have shown that two pairs of the sides are congruent. Now, then let's go back to our things that which we needed to prove. Where is DW? DW is the outer line, and LW is these two outer lines. And how about KW? KW is the corresponding size, hypotenuse, and CW is the corresponding hypotenuse, and KW is the corresponding legs. So we can simply write that up as a corresponding sides are in proportion. So number 7 would have been DW over LW is equal to CW and KW. The reasoning is corresponding size are in proportion in similar triangles.